We were talking to the Otago Regional Council, who made us aware of issues going on down here in the lower Taiari with these two shallow coastal lakes. No one's really written scientific papers about these lakes. The best way to find out where to start a research program would be to take some sediment cores and to look at the history of these lakes and how they've changed over time. We went out into the middle of Lake Waihola, which is 2 meters deep, and we used a push core method to get a 1.8 meter long sediment core from the lake. To most people, it just looks like mud, but to us, was just an amazing reservoir and store of information, microscopic organisms and chemicals and things that tell us about the history of not only the lake, but the catchment in this area. While we had the core intact still, we took it to the Dunedin Public Hospital to get x-rayed, because x-raying cores is a really useful way of getting a picture inside the core tube. What came out almost immediately that was fascinating was that near the bottom of the core, we had a quick look at the x-ray that was taken, and there was this amazing layer of shells. And the shells were not just broken up shell material, they were shells that were still articulated. In other words, the two halves of the shells were still together, and they were in living position. So these were shells that weren't washed in from the sea. These were shells that represented things that were actually growing in Lake Waihola. They looked like cockle shells or Ostrovenus stutchburii, which is an estuarine species, and they don't exist in the lake today. So right away, we were pretty enthusiastic and excited about this result. So then we proceeded to do our detailed chemical and biological analyses of the core. Over time, the more and more information we gained, the more we were able to put a story together of what had happened to these lakes and to this area. It turned out that we had at least 6,000 years worth of sediment. So we were able to date those shells quite accurately, and they were just around 4,000 years old. So already we had this story that these lakes were basically part of an estuary 4,000 years ago. We scratched our heads a little bit about the salinity and what could have caused this salty period 4,000 to 6,000 years ago. And so we looked in the literature, and we found out that sea levels have varied a lot during the Holocene. The Holocene is this period of time since the last glaciation, so it's about the last 10,000 years. And right at the early Holocene, when the glaciers were still melting, sea level was far lower than it is today, like around 150 meters lower than it is today. So this area would have been a freshwater wetland area. And as the glaciers melted and the sea level rose, it achieved its current sea level around 6,000 years ago. But in parts of the globe, there was evidence that it had slightly overshot the current sea level for a short period of time by maybe half a meter or a meter, very small amount. That became our best hypothesis for why this system was saline 6,000 to 4,000 years ago. This period called the mid-Holocene sea level high stand, where the sea level slightly overshot the current level, probably was enough to turn this freshwater system into a estuarine system and make it a good home for cockles and other estuarine creatures. So like probably flounders, mullet, those species still come into these lakes, but at the time, it would have really been more estuarine and less freshwater. This system is very sensitive, being tidal. It's very sensitive to sea level. If the sea level rises a little bit, it becomes salty quite quickly. If it decreased, it would become freshwater quite quickly. So it's right there. It's the canary in the coal mine, really, telling us about sea level variation in the past. And it also means it's going to be very sensitive to sea level variation in the future. And as we know, sea level has been rising for the last at least 150 years around New Zealand. When small changes happen, big changes in biology happen. So it's a really fascinating system to study from the perspective of environmental change. Where today we have climate change, and as as the oceans warm up, we have sea level rise due to thermal expansion of the water in the ocean. So we know that's happening, and that will continue to happen. But we also have increasing demands on our freshwater resources. In some places, we're going to have higher amounts of droughts. So agriculture is going to need to take more water from rivers, lakes, groundwater sources. And that means lakes like these lakes will get less freshwater input, which will just exacerbate that saline influence. And so by studying these lakes, we kind of have an idea of what that will look like in the future. It's kind of like going back to the future, because these systems had the mid-Holocene sea level high stand, which showed us what they look like when there is more salt water in the system. So it's been an extremely interesting system to study, and I think there are many lessons in studying this system and what we've learned for the future, for managing and for adapting to future environmental changes that we know are going to happen.